So welcome to Module 8, Activity 3, and in this module we're going to take a look at a potentiometer controlling a DC motor in terms of speed. So the next part of this piece is we're going to take a look at connecting the potentiometer and the DC motor to the all-in-one robotics board. As you can see here, we use the DC motor connected to the terminal block. It's your choice if you wish to connect it to DC motor 1, 2, 3 or 4, and as you can see, each one of those terminal blocks is numbered as such. The PP3 is connected to the terminal block again, as we've seen in previous modules and previous activities. But the potentiometer, as you can see on the far side, is connected to GND and 3 volts. That's the two external pins. Now it doesn't matter which way you connect it in. Either you go with the outside left to the ground and the outside right to the 3 volts as seen here, or you can swap them. The only difference is that the rotation of the potentiometer will change the resistance. So if it's connected one way, rotating it clockwise will increase the resistance, and if you swap those two wires, well then it will go clockwise, will actually reduce the resistance. The key thing that needs to be constant is the middle leg there. That middle leg of the potentiometer needs to go to P0, P1 or P2, and as you can see here, we've connected it to P1. As written on the text box on the right, it states that connecting the inside leg to one of those is an analog input, so therefore it can read the distance or the differing variables or the differing resistance coming from that potentiometer. Now, as per usual, we're going to go back to key quiz model here, and again we need to plan, code and test this, and then an iterative process will take place in order to prove that it's the best and most effective way to code it. As you can see here, the first thing we need to do is we need to plan and understand the problem. So looking at the problem, what is it? Well, we want to control the speed of a DC motor using the potentiometer. Then we need to code, and we need to use coding blocks to create this sequence. And when we look at the code blocks we're going to be using, they sit within basic, they sit within robotics, variables and pins. And we'll show how this comes together in the next slide when we see the actual code in action. Then after it's all been done, we use the fourth step of the code. We turn around and we apply it to the model or the product, and we make it work in real life. So moving on to the next slide, we're going to see what happens in terms of the actual code itself. So as you can see on this slide here, you see the forever block maintains this code running in the background constantly. Using variables, we set the potentiometer to a value, and as you can see here, it states that the value is coming from the P1, which, as you can see in the diagram, the wiring diagram, is the middle leg of the potentiometer. The resistance then from 0 to its max of 1023 is being mapped to a speed of 0 to 100, and then from there then that is controlling the motor and making this motor go forward at the speed of the potentiometer and the way in which it's rotated. So therefore, if we spin the potentiometer halfway, it will make the motor go at 50% of its speed, and if we spin the potentiometer all the way up, it'll do 100% of its speed. And also alternatively, going back to 0 will make it go 0 speed, so stop the motor. So we're going to see that happen in action now in terms of coding it in the next part of this video, and I'll take you through that now in a couple of seconds. Okay, so welcome to this part of the module, and in this part we're going to take a look at coding the microbit in order to make this work and create a scenario where the potentiometer is going to speed up and slow down the DC motor. Now, if you've engaged with the previous activity, the coding blocks of this are nearly identical to what we've seen before. What we're going to be using is roughly 90% of the same blocks and the same idea and the same code. So how do we do it again? Well, very first of all, we're going to start off by creating the variable. We're going to go make a variable, and we're going to call it either potentiometer, or we can call it whatever we wish, but it makes sense to call it the potentiometer for this one. Now what happens then is we're after seeing a couple of different things. We can set the potentiometer to a value, change the potentiometer value by plus or minus 1, plus or minus 100 and so on, which would be quite useful if you wanted to turn around and create a countdown, as I've said before. Now, as we look here, then we've got the potentiometer block, which allows us to map that variable or to put that potentiometer value onto something, which we'll be using in a few minutes. So what I'm going to click on now is I'm going to click on set potentiometer to a certain value, and we're going to put it into the forever block. So this is going to constantly do this in the background and constantly keep it running. The next part of this then is we're going to go down to pins down here at the bottom of the list, and we're going to bring out this big mapping piece that we've done previously before. So bring out the map and add it into that block over the value of 0. If pins doesn't exist for you, like I've just shown you here on screen, just click on the drop down arrow underneath advanced and you'll see it come up down there. So what we want to do next is go back to the pins option, and we're going to use the analog read pin, and I'm going to either change the value depending on where the potentiometer was connected. For me, the potentiometer was connected to P1, so I'm just going to add that in there at the top. So I'm going to map the analog read pin P1, which is the value of resistance or value coming from the potentiometer. Now, when we look through the code, we need to figure this out. So first of all, we're going to map the varying resistance or map the varying input coming from the potentiometer from 0 to 1023, which, as I explained before in previous modules and previous activities, that 1023 is the maximum resistance that some of these potentiometers are putting out. So I'm going from the 0 to the top range of resistance coming from the potentiometer. And I want to map that to the speed of the servo, or sorry, in this case, the speed of the DC motor. And from our own knowledge of it, the DC motor in terms of microbit goes from 0 to 100. So I'm going to do that there. So basically what that means is when the potentiometer is at its lowest resistance of 0, it's going to have a speed of 0. When it's at its maximum resistance of 1023, it's going to end up at a high speed of 100. So it's at max speed of the DC motor. So if we take that into account, if we end up at around the value of 511-ish in terms of resistance, that would roughly be halfway in terms of the speed of the motor. So roughly map it to 50. So hopefully that explains that a bit clearer. What we're going to do next is we're going to use the robotics tab again, similarly to what we've done before, except instead of using the servo motor, we're going to use the DC motor. So once you see it here, the DC motor, we're going to make that move in a forward direction at a speed of whatever we so wish. Okay, so we're going to make motor 1 move forward at a speed of whatever. And as I've said previously before, what we're trying to do is we're trying to take the value of that speed from this range here. So how am I going to do that? Very simple. Just go back to variables, click on potentiometer, and drop it in here over that one. So that's the code done. That's it finished. And as you can see, it's quite simple and quick to put it together, but the thinking behind it takes quite a bit of time to figure out. But once again, forever, constantly going to be doing this in the background. It's going to set the potentiometer value to whatever is coming in from the middle leg of the potentiometer. And as we've said in the learning log that we've connected to P1, it's going to take the range of resistance. And as I said, if you wish to calibrate it and make it more sensitive, well, then you can look at what is the top range and what is the lowest range coming directly from the potentiometer using the different things that we've put together, such as the calibration code. And I think it's at the start of this activity. There's a QR code that will take you to it. And also then as well, you can map it to the top speed of 0 to 100, which is the top speed of the DC motor. If you wish to make the DC motor go slower at its fastest speed, you can just change that value down. But as I said, 100 is the max that we have for DC motors. And then once we see it here, it's going to turn that motor forward at whatever the map piece is here from the potentiometer. Okay, so that's the piece here in terms of the potentiometer making the DC motor move. And hopefully we've got some learning from this. We're going to see this in action now in the next part of the video.
So this is for Module 8, Activity C, creating a variable speed DC motor drive. So as in the previous activity, I have my potentiometer hooked up to my all-in-one robotics board. Pin 1 is hooked up to the 3-volt supply. The wiper is going to pin 1, and our code in the learning log is telling the microbit to read the analog input on pin 1 coming from the potentiometer. The ground connection, so the third pin on my potentiometer, is going to the ground connection on the header pins here. I have a DC motor and I have it attached to motor output 1. So as I begin to rotate my potentiometer, I should go from stationary motor I'm getting a small bit of movement, and as I increase my potentiometer, my motor will get faster and faster. Until when my potentiometer is fully open, 100% of the power available from the battery is being directed through to our DC motor. So we're going at full speed, and then by rotating our potentiometer down, we now have the motor turned off where it's receiving 0% of the power due to the mapped value of our potentiometer being sent as a power signal through to our motor.